All right, so this is week 4 of NTI, factoring and rules of exponents. We'll be looking at these rules of exponents and factoring to continue on with our review before AB Calc. If you remember this page, know these algebraic operations, it's on your trig worksheet that I gave you last. It had trig identities on it, and you can grab that and use that to remind yourself. So some of these are pretty memorable, but others are a little more obscure. There are a lot of these simplify with rational exponents problems, and I'm only going to be able to do a few of them, so that's why you only see a couple highlighted. So we're going to go ahead and jump down to this one, which is the cubed root of radical 64. So what you want to do is change this to change these radicals to powers. So I have the half root, or the half power of 64 to the third power. And this is a power to a power, so you could take the 1/2 and multiply by the 1/6, but I'm just going to work inside out. Now, it's not very hard to take the square root of 64 and then take the cube root of 64, but it's important that you know how to switch these radicals to fractional powers. So you carry that out and you get 2. The next example I wanted to look at is this 2x minus 1 to the 4/3 times 2x minus 1 to the negative 1/3. You can see the bases, 2x minus 1, are the same. So that means we can actually add these powers that you see in as the exponents. So we'll add 4/3 plus negative 1/3, and that gives us 3/3 or 1. So we just get 2x minus 1. This next example, E, has division between two bases with powers. So we can subtract this negative 1/2 power from the single power that's on x minus 1. Or we can, which I'm going to do, I'm going to rewrite x minus 1 to the negative 1/2 as x minus 1 to the positive 1/2, and then add the powers together, because I like adding them better and getting rid of the negative exponents, which you'll also do on quizzes. So there we go, we add it together, we get 3/2. All right, moving along, it's really important to use the greatest common factor. When you are factoring, it's going to simplify these problems greatly. So the first one I wanted to look at is this 6x cubed plus 4x, and factor out a 2x, and you're left with, should be 3x squared plus 2. And I didn't show that in my recording, but there you go. So that's why I reviewed this. So the next one I wanted to check was just another one with common factors that are binomials. And of course we've got x minus 2, and we factor that away from 2x and 2x times x minus 2 and radical x. There we go. All right, and then another thing you should remember is the difference of squares. This is going to make your life a lot easier. I wanted to work over here with J in particular to show how difference of squares is going to work. Yeah, we have 1681. Those are definitely squares, and x to the 4th, that's a square. So if you don't remember difference of squares, you are subtracting the square root of each term and then adding the square root of each term and multiply those two binomials together. And here's a general formula for it. You've got a minus b and a plus b. Remember that these are conjugates. They've got, when multiplied together, they create a difference of squares. And sometimes this is useful, as we've seen, with trig equations. And then if we move back down here, it's important to remember that 4x squared minus 9 is still a difference of squares. So we can factor that, but we can't factor 4x squared plus 9 because it's a sum of squares, and that's not factorable. Sweet. Okay, so I wanted to tackle this big monstrosity here just to factor it a little bit. And it's important to find the GCF hidden within all this. So you'll notice we have x to the 6 plus 1. We have 4 of them here, but then we have 5 here. We've got coefficient. This one's really tricky to find. We've got 3 in there. But, I'll come back to that. We've got 3x plus 2, and we've got 2 of them here, 3 of them there. But there's a 3 and a 6. So I have a 3 in common between each of these terms. So that's why I'm going to write my coefficient first. And then I'll start factoring away 4 of these x to the 6 plus 1s, because I've got 4 of them in this whole term and 4 of them in this whole term. Then I've got 2 of the 3x plus 2's here, as well as in this term. So I've factored everything in common away first. And now I'm going to multiply in what was left over from those factors, from that factor. So in this first term, I completely factored away the x to the 6 plus 1 to the 4th. So that term does not exist. So that factor does not exist in this term anymore. And then I factored out a 3 from the 6x to the 5th. So it's 2x to the 5th, because that's my coefficient that I took away. And then in the next term, I've factored out just one of the 3's, so I leave a 3. And then my 3x plus 2 squared is not present because I factored that completely out. But one of the x to the 6 plus 1's is left over. And that would be how I would have to leave that answer. And I do try to see if I can factor out anything from this term, and I tried multiplying through and simplifying, and you'll see when I get down to this result that there is nothing I can factor from these terms. There's nothing in common. It looks really close because it looks like there ought to be a 3 between each of these, but this is a 20 and there's no factor of 3 in 20. So this is about going to wrap it up. The trinomials, you've factored a lot of trinomials. I'd like you to try these and see how well it goes. You can pause this screen if you'd like, and you can try them for yourself. I'll be on explaining factoring by grouping this week during our sessions. So if you have any questions, please log on there, and we can talk about them for the quizzes. Thanks for watching, and I'll talk to you guys this week. See ya.